Okay, so we are just going to continue the practice on how to analyze the data set. So first, let's import the libraries. So we are going to need all the libraries, NumPy, Panda, Seaborn. From the Seaborn, we are going to continue the practice on Iris dataset only. So just import all the needed libraries before we continue the practice. NumPy as NP, Pandas as PD, Seaborn, and then matplotlib pyplot library. And then we are going to load the Iris dataset. We're just going to continue exploring this Iris dataset in today's practice as well. So the load data set is the function that will help you to import the data set from the library. So we have imported the Seaborn library as SNS. So by using the load data set function, we are just picking that Iris data set, and then we're just displaying the top 10 rows from Iris data set. Okay, so this is the basic. We just imported the data set so that we can continue our practice. So what we're going to do today is to do some more customization on plot. For example, we have done all these plottings and histogram. Today we are going to do some more customization things, like how to change these. These are the default color. By default, the plotting will be in this blue color. But if you want to change the color, how can we change the color? For that, you have to use the parameter called color, and you can specify any color. And then if you want to bring the transparency in the color, you can use the alpha parameter. It may normally, you know that the alpha parameter takes the value between 0 to 1. So 0.5 means middle of the transparency, and the figure size, that means the window size, is going to be, we're just specifying 10 times. So how many features are there? Based on those many windows in this size will be displayed. Okay, so in this practice, we are going to know like how to customize the plotting, how to change the color, how to bring the transparency in the color, those kind of stuff. Before that, what I'm going to do, I'm going to drop that last column in our head. This species, we don't need this classification species. So you know the function, what is the function to drop a particular column from the data set? If you recall, the function drop can do that. So the data from DF is going to be, we have said this in object called iris, right? So iris dot, we're going to apply the drop function because iris already, what we have done the importing of SNS. So all the Seaborn library built-in functions can be accessed through the iris function. Okay, so what we are going to drop, we are going to drop the species column. Okay, so we are going to drop it before we practice this customization of plotting. Okay, so and then let's be familiar. Different function, what it will do, it will find out the different, like how cumulative summation will do the summation of the all the values in the column. Likewise, the diff function will get the difference between two rows. And you know the head function, what head function will do? Head function will just pick the top 5 rows. By default, if you're not passing any parameter to this head function, it will pick 5 rows. But if you pass any value, that many rows will get picked. So here, if I pass 10, sorry, it will pick 10. But if I'm not passing any value, then it will just, by default, it will pick 5 values. So what it has done, it finds out the difference, what it has done. What is the first value? 5.1 minus 4.9. What is the difference? Minus 0.2. Like that, the next value, the first value will be subtracted. Sorry, the next value will be subtracted from the first value. Okay, so we are just finding out the difference between the next adjacent rows. Okay, and then we are saving that as a object called diff object. Now what we are going to do, we are going to plot this value. We are going to plot this value. So since we are interested in plotting this value, you have to say df. Okay, since if you have saved this somewhere in an object, you can call that object, but we didn't save it. So I'm just going to call that function. And on that, I'm going to apply the histogram. So histogram is the function name. Okay, that we are going to plot the histogram, and color is the parameter. So that's what you're learning here. Color is the parameter. So R means red. So in Zybook, you might have learned what are the different color notation, what are the different symbol notations. So we can apply all those, but since it is histogram, you don't need the symbols. So we are just applying the colors. So alpha is the parameter that will take care of the transparency level. 0.5 means middle transparency, and the figure size is going to be 10, 10 or 5, 5. You can give any square size figure. So if you plot, you can see what is getting plotted. Okay, so you can see the first value is minus 0.2. You can see minus 0.2, minus 2. You can see that normalization is value between minus 2, minus 1, 0, 1, 2. So the difference in the features, is getting plotted here. So all you are noticing here is how you can change the color values. So let me do one more. Here, this time, I'm just going to apply it directly on the DF. That is not done the difference. I'm just going to apply it on the iris dataset directly. So you can see now what you see here, the feature values, not between minus 2 to 1. This is different value, but this is the feature value. If you look at the feature, the normalized feature is going to be like 5.1, 4.9, and that is what getting displayed here. Okay, so whatever you want to apply, just apply and apply the histogram on that. So in this previous practice, we have applied it on the difference between the two rows. And here we have applied it directly on the data set itself. Yeah. How to do scatter plotting? Scatter plot is like you can take different features, and for example, if you see here in this plot, I have just picked the sepal length and length as two feature. I have just plotted the sepal length in the x coordinate and sepal petal length in y coordinate. Like this, I can just plot two features together in same plotting by using scatter plotting. Okay, so we can compare the we can map the two features together. We can map the two features together in single plot by using scatter plot. To do the scatter plotting, you can see we have to call the functions called scatter. And what we need to do, we have to specify what needs to be there in x and what needs to be there in y. Okay, so we can simply pass the column name and assign it to the x parameter, and column name assign it to the y parameter. So that will do the job for us. So we have saved the iris data set in the object called iris, and we're going to call the function plot. The plot function has a lot of sub functions. We are going to call the sub functions of the plot called scatter. Okay, so this is how you can do scatter plotting. Iris object, plot function, scatter sub function, x parameter where we want to plot the sepal length, and y parameter where we want to plot the petal length. So if you pass this, you can see this. The same thing if you want to do that petal length, sepal width and petal width, or you can just interchange whatever you want to plot. You can just pass that as a parameter. So for example, if I'm going to plot these width column of both sepal and petal features, then I can simply call the column name that will plot that. It doesn't need to be two feature. Since it is 2 dimensions, it doesn't need to be 2 features. You can do three features too. How? Let's see. If you want to, if for case when we want to do the third feature, still that is possible to do the third feature. Maybe we can just do it as a third. In other advanced libraries, you can do multiple dimensions together, but in basic plotting, if you want to do that third feature, how can we do that? Just add that. For example, if we want to do the sepal width here, what's the attribute? Unknown attribute, sorry. So we have to say it as C. C means the gradient value. We cannot do it as the Z dimension. It is gradient value. The third feature should be passed as a color gradient value. You can see the X coordinate takes the sepal length and Y coordinate take the petal length, and the color gradient value is assigned with the sepal width. That is how we are plotting. So we can maximum plot 3 features in a plot. The third feature will be assigned as C parameter. So note down these parameter value. You can expect this in your quiz. C will be for color gradient. Okay, so that helps you to know the scatter plot. If you want to do the labeling here, so what is what like that, if you want to do the labeling, then there is a parameter called label that takes care of this. For example, here we are just focusing on length of the petal and sepal. So here we want to provide some label for that. So in that case, what you can do, you can just pass a parameter called label and just assign what is the label name. The label name is length. So that length, that labeling can be done. If you want to do it for width, you can simply say width, and the labeling of width can be done. Okay, shall we do that for width? So I'm just the reason for doing multiple practice so that you will be familiar with that at least. So the parameter label of the scatter plot will take care of that legend, that is title. So here we are just focusing on width. You can see wherever the space available. See here, there is no space available. So automatically it will pick some space, available space, and just add the label and whatever the color based on, it will just specify that whatever you hide, that it doesn't read it automatically and do it. You're just specifying what is the label that you want to be. And if you want to change the color, how can we change the color? So right now it's in the same blue color pattern, right? But if you want to change the color of that, you can change the color. For that, you have to simply add one more parameter called color parameter. So let's do that. So see, in the Zybook, I have a, you can see that what are the names that you have to give for color. You can check it, or I can give you a cheat sheet for that. But you don't need to worry much about that. Normally, black means B, red, R means red, G means green. Mostly it will be like that. You can refer the cheat sheet for that. So next thing, if you are going to increase the diameter of the plotting, how can we do that? To increase the diameter, you have to use the parameter name called yes. You have to call the parameter yes to do that. Okay, so let's do that. I want to do that with this width. So with the label, I'm going to add a parameter called yes. So yes is the parameter that you have to use to change the size. For example, if I want to fix the pixel values to 500, then you can see it is too big. So if I want to change that to 100, you see, like that, you can change the size. So the size of the plotting, diameter of the plot can be changed by the parameter called S. So note down these things, take notes on these things. You can expect some quiz on this. Okay, S is the parameter. The next thing, how to change the shape of that. So far it is only round, right? So how can we change the shape? For example, if you want to do the hexa plotting like this, hexabin plotting, like say hexabin plotting. So if you want to change the size of the plotting to hexabin, then instead of using scatter, you have to use this function called hexbin. Okay, so this hexbin function, that is also sub-function of plot. Scatter means round plotting. If you want to do the hexabin plotting, you have to use hexbin, and whatever you want to do plot. The grid size, all those things you can specify. Okay, so here in this exercise, you came to know how you can fit this. Do you see this plotting? So this grid size, you can specify the grid size. I say 5. It will be between this 5. If I say 10, based on the size, whatever you have given, based on that, it will just pick some size, pick the size, given size, and do the hexabin plotting. With that, so next we are going to do how to do the pie chart. So the next we are going to see how to do pie chart. Okay, you might have seen pie chart, right? So you can do pie charting for each row, each data, each particular data. Okay. So for example, if we take our iris flower data set, if you want to plot the width and length of the we have the sepal length, sepal width, petal length, petal width. If you want to plot the ratio of those features for each row, then how can we do that? That is, pie chart is the best way to do that. Maybe already we have dropped the, what is that in our DF? Did we drop the, yes, we have dropped the species, so we can take it as it is. So what we can do, we can just take one row. So we have already seen the ILOC function, index location. ILOC function will help you to pick a particular row based on the index positioning, right? So normally 0 means the first row will be the 0 index. So we are just going to take that first row and we are saving it is in the object called D, and we are going to plot it now. Okay, so we have just picked that first row and put it in the object called D, and we're just going to do some pie chart. So pie chart, as usual, pie is a sub function. Again, all those plotting should be a part of the plot function. Okay, so we're just going to we are going to apply that plot on the D object, call the plot, and from the plot, we're going to call the pie. Okay, pie is the function to create pie chart, and we can just specify what is the size that we want. If you want a small pie chart, then say 5. So it gives the ratio of each feature. So you can see the petal width is very low. It's between 0.5 some value. So you can see the ratio of each features. We can do the comparison of each features in that. So if you want to change the size of the plotting, you can say 10. Okay. So pie charting. So whether it's we can do only for one, no, we can do it for multiple rows together. For that, first we have to normalize it. Because right now we have to plot all the columns, but right now it is the horizontal. First we have to change it to the vertical so that each column will be taken as the value of a particular data, particular flower. Okay, so for that, how to do that? There is a function called transpose function that will help us to convert the horizontal data to vertical data and vertical data to horizontal data. So we have our D here. So from the DF has the whole iris data set without that species column. And we want to just check the first 3 rows. You know the head function. What the head function do? Head function will just pick the given number of row and pick. Okay, now we are using the head function and we want to pick the first 3 rows. And the function called T. T means transpose function. If you apply it on horizontal, that will convert to vertical. The vertical will convert to horizontal. So the simple character T is a function, transpose function. The T is the transpose function. Note down all these things. Note down all these things. T is the transpose function. Okay. And now we can see what we have done here. We have just converted the row data to column data where each 0, 1, 2 is row. Okay. Each row is converted to column value and the column is converted to row value. So now we can just pick each column. All the first image, first flower values are here, the second flower values are here, and the third flower values are here. So now it is easy for us to draw some pie chart on this. How can we do the pie chart on this? So D dot, again called the plot function, which is the parent function for all plotting. And then we are going to apply the pie. And here, each flower is going to be a different pie chart. So we are going to apply the subplots. When you say subplots true, then only it will pick each features and convert it as a separate pie chart. So you have to say subplots. So note down this subplots is the parameter that should set to the value true to create subplotting. Note it down. Okay. Is you can just give any figure size. Let me give small values. Oh, it's very small. So I'm just going to take it like 10, 10. Oh, figure size 10, 10. Okay. Like this, you can even plot for 100. If you apply it on head function, how much you want to give that many features. But you have to first convert that rows to column. Okay. And you can do further customization if you feel like this font size is bigger. Okay, you can change it. You can just change the font size of this by using the font size parameter. Let's do that. Let's do customizing the font size. Font size, you say 10 or 8, let's say 8. And auto PCT. This will take care of, oh, it's very small. Okay. So it will give you the value. So right now there is no value here, but if you want to see the value that you want to display that in the plotting itself, then you can say auto PCT and you can say the decimal value. 2 decimal notation. In that, I want to display the values in each plotting. So you can see the value of each plotting is displayed here. Percentage will be displayed. So 31% sepal width and 18% petal length. Like that, the ratio will be plotted on the graph itself. For that, you have to use the parameter auto PCT. That will display the ratio. That will display the ratio. And if you want to give some column indexing to these colors, you can do that by using the parameter called index parameter. Okay, so if you add the index parameter and you can just specify some indexing value to this. Okay, so I'm just going to okay, let me take new one. So I'm just going to create a new, if you remember, we have in pandas, Do you remember the series function? The series function is the single column function, right? Let's call that series function. The S should be uppercase. Series function and say 0.2. We're not applying it on the data set. Let's do it on some other values. A, B, C, D. 5 values, right? So let's give 5. It should be indexing should be in array. So we have to specify the index value in square bracket. Let's make a list. So name, you can give the title by using the parameter name. That is the reason why I'm practicing. I'm giving this practice. In each practice, you will get to know different parameters. So the name is the parameter that will help you to give the title of the plotting. So pie chart, whatever title you want to give, you can just give. So we are not applying it on any data set. We are just simply creating our own data set with this formula. We are simply creating our own data set, and then we are just applying some name and indexing. So let's draw this. Series is the object name. Can you tell me the function? Plot. And what do you want to draw? Pie. So if you apply it, you can see the indexing that you have produced, index A, B, C, D, E that got plotted. And also you can see the title there. Whatever title you have given, the title is visible in the plotting. Okay, so if you recall, initially when we work on the data set, we just plotted our iris data set like this. If you want to plot each feature separately, how can you do that? Now you know the parameter called subplot. Can you apply the subplot on this and see whether it picks each feature and plot it separately? Shall we try it? In the previous practice in the plot, we just plotted all the features together. Shall we plot differently? Yeah, how can we do that? So we have our iris data set in the object called df. So apply plot, and let's do the normal plotting. We don't need to go for any. We can do we have done the subplotting for the pie chart. Let's do it on the normal plotting. So what the value of the subplot should be? The parameter subplot should be true. If you say subplot's value true, that is simple enough to create what? What's that? Subplots, yes. The parameter value should be subplots. Okay, the parameter value should be subplots too. That will pick each features and draw it separately. What if you want to customize it? It just picks its own size and just displays it. You don't like the size. How can you customize it? You know the parameter called figure size. Good. The figure size, we can just do that. Or layout. And also we can customize the layout. How many rows, how many columns that you want to do that. Like I want 3 figures in the top row and 2 like that. You can customize that too. So how can we do that? Let's continue. You're just learning different kind of customization in the plotting. So let's say cell X parameter. I'll explain what is that. Layout. So we are going to say I want to do layout with the figure size. Figure size 1010. Then PLT. You have to call the function called tight layout. Okay. So TI. You can see we asked you to display 2 2. in the layout. So it's just fixed to 2. And the figure size, whatever we have given, we picked up. So like that, you can customize it. You can just change the size. You can change the layout. It's totally, you can customize anything with those parameters. Last plotting that we are going to see on the data set is called scatter matrix. It's a very powerful function in terms of data analysis, where you can just look at the features as a separate matrix values, row and column value. The scatter matrix is a really powerful total analysis function. If you want to analyze the total data set, then you can just simply apply the scatter matrix function. So scatter underscore matrix, underscore matrix is the function name. Here, the first parameter is going to be the whole data set that you want to analyze. We want to analyze DF, right? So the iris data set. So DF, that's where we have saved it as a DF. And then we want to do the matrix. Each matrix, I'll show you what the scatter matrix will look like, so that we'll get some idea. Scatter matrix will look like this. You can see the sepal length value along with each variation. Okay, the sepal length and the sepal length comparison of sepal width, like that you can do the whole comparison of scatter matrix. So I have first let's see by using the help function, you can simply, if you don't know what is the syntax, what is that particular function will do, then you can simply call help function. Always use this facility. If you want to know about some particular function, use help and pass that function to that, so that you will get to know the syntax, everything. But before using scatter matrix, you have to first import it. We didn't import the scatter. For that, you have to import a separate library. First import that. From pandas, you have to import that scatter matrix library, because this is a data analysis thing. So pandas is the data analysis and data manipulation library. So from pandas, as part of the plotting functions, we are going to import the scatter matrix function. First, you have to import if you want to do the scatter. I think I have given you one homework from the scatter matrix. Okay, so to do that, you have to import this library. And then if you want to know what is this help scatter matrix function and how you have to use it, you can just call the help function and pass this function to that. You will get to know what this scatter matrix will do. So scatter matrix is part of plotting, and you can see what are the parameters that you have to pass. Data frame, alpha transparency, figure size. So they have explained what is what is the parameter, what is each parameter will do. Okay, so you can just use that help for any function in case if you want to know detail about the syntax. Okay, now let's see what the scatter matrix will do. It will do the comparison of each features. It will do the comparison of each features. So scatter matrix, to that you're passing the data set as the first parameter, because look at the syntax. What is the syntax? Frame. What is the frame? DF is the frame. You can see if you plot the matrix, it will just create it like a matrix. Do you see it's a matrix? Sepal length versus the petal width, sepal length versus petal length, like that. You can just create each features against each feature like a matrix. So that is the use of scatter matrix function. So let's do a small recall on what we have practiced today. So in the last class, we have practiced, we got introduced to data set, how to import data set and how to play with the data set and how to explore the data set by using different functionality, normal plotting, histogram plotting. And then today we discussed about how to do the cumulative summation differentiation and how to plot those values. What is scatter plotter, how we can customize the scatter plotter and how we can use the different parameters to customize the color and the features, number of features, and then pie chart, how to customize the pie chart and how to do the subplotting and what is scatter matrix and how we can use the scatter matrix function to compare, analyze two different features of the data set.